Hello everyone, my name is Nathan, otherwise known as Old Man Builds, and today we're going to be building some circuits. Gerald will be here in a little bit, but I have a fun one for you today. We're going to do a high voltage multiplier circuit. Not really hard, just a lot of repetitive parts. So it does kind of break the 10-part rule. However, it is the same repetitive part, so it should be fairly easy to do. We are joined here today by the Benny Factor, Ben. How you doing, Ben? Ben, hello?
I'm good. How you doing, Nathan?
Doing great, man. Just checking in on you. We're going to get started here on this circuit. Feel free to chime in at any time.
Project is extremely
Awesome.
high voltage, so
I'm gonna go set up at a mini lab, and I'll set up the camera so if I can build along with it. I don't know if I have all the parts, but
well,
yeah,
this one you won't. Yeah, this one you won't have all the parts too. This is all special.
Oh, that's okay. I'll still try to follow along with my camera on my mini lab.
Okay.
don't worry, I'm going to show it again later and explain it. This is a voltage multiplier that I've already built, and I just wanted to take the time to show you the back diodes. It's important the way they go in. On the front here, we want a clean look. We just want to space them out evenly. We're going to start here with our plain prototyping board. Again, this is not the green one. This has no metal in it. It's just a plain board. This part right here is pretty much up to your discretion on how you want to place these in here. All I would say is you want to keep it neat and clean, make it nice. So take your time, count out the little holes, move the things around. It's just important that they line up in a row. And
Hey guys, by the way, this is a negative multiplier circuit. It's not the positive side, so you know.
Keep 3 holes in between each capacitor. That keeps it pretty even all the way down the line. Now, it's just boring and tedious process you have to do here. And I'm going to skip through this just a little bit, just so that you can see that they go in there evenly. Once we get to 6, we're just going to go ahead and repeat the same process on the other side. Now that we have them all put in place, we're going to go ahead and turn this board over. And we're going to take a look real quick at the original that we started with. And then we're going to go ahead and make ours just like it. We're going to start here at the bottom. These two just hang off the end here. Don't worry about them. Let's go on to the next ones. We just cross each one over in a row going down the line. Once you get all that done, the top two, just like the bottom two, will go off the end of the board. Now all the ones we crossed over each other have to be soldered together. There's a couple ways of doing this. In this one I'm going to show you right here in the beginning. We're going to go ahead and solder it and then cut the ends and clean up the solder. And I'll show you another way in a minute. This is the second way to do it, and generally the way I prefer to do it. Once they're crossed over each other and you know the size, then go ahead and just cut them off, line them up, and we're just going to solder them like that. When you're doing this part, just take your time and do it. Sometimes these things bend funny, sometimes they're not pushed all the way in. It's just kind of annoying, but you have to kind of get through it. When you're done cutting and soldering them, they should look just like this.
One thing real quick, guys, just so you know, every time you leave a sharp edge on any one of these solder joints, or if you leave any one of these wires sticking over, that's a potential sparking point. It's a breakout point. So what you want to do is you want to see everything go smooth. So just flow the solder over it until it's smooth. Any excess wire, make sure it gets cut off. Make it nice and clean. Now that we're all cut and soldered up, let's go ahead and take a look at the 2 pieces of metal that we hang over the side from the capacitor. You can see that we're going to start our first diode right here going directly to one of those. I know I just skipped over a little bit and soldered a bunch in, but the most important thing here is to look at the direction where that little gray strip is. That's the most important thing. One other thing, the only thing that separates this, the negative side, from a positive side, is that the diodes are run backwards. So you'll see the little line, the little gray line that's in them. It would just go to the other side. It just flips right over on every single one of them all the way up. So you just get an opposite thing. So it'd be like putting it in a mirror. You get two opposite ways. That would give you the positive and negative. This right here is just the negative. So I didn't build a positive one on this video.
When you put in these diodes, just make sure it matches this. Just to show you how I do this, I go ahead and I put the diode over the top. I just cut it to length, right so it sits right on top of it. And then I go ahead and solder it in. One thing to note when you do this, you don't want to leave any sharp edges. So when you smooth that solder over, make sure it's nice and clean and smooth. When you're going from left to right like this, I like to always solder in the side that has only one connection going into it first. Then I bring it back over to the other. Once you get your size cut right here, you're going to want to put your thumb right over the two diodes themselves. And you're going to want to hold this thing down while you put some solder on here. It's just a lot easier. It makes it connect easier. And you don't have to mess around with stuff.
Those pesky things like to pop up if you don't hold them down.
At the top and those two pieces of metal we left hanging over from the capacitor, we're going to connect to those now. As we put in these last two diodes, again, I just want you to take a look at where they sit in comparison to the capacitor. And now let's put in that final diode so we can complete this project. On the left side here, the metal coming from the capacitor is now unneeded. The other side we leave long because it's the power side. At this point, our voltage multiplier is complete. Let's go ahead and compare it with the original, and let's make sure everything turned out right. As you can see, everything matches up. We did a good job. Now it's time to test this thing. Again, I just wanted to make sure you use all safety precautions. Okay, so we're going to compare right here. Here is our battery on our right side and our ZVS. Again, here we go. I only have one side connected right now.
One thing I will tell you guys, when you look at those batteries, there's a positive and negative side on it. So if you line up your battery the same way as mine, the top one is the positive, the bottom's the negative. The two in the center are for data, so you don't need to worry about those. All you need to worry about is the top and the bottom there.
The other side is this far side. These two are communication in the center, and that's our negative right there. The white was our positive going on this one. So we have it there. We go to our flyback right here, AC flyback. You can see it goes over on the bottom side and under on the top side. Again, two wires coming off. Exactly what we got here. Then we go ahead and look each wire. They're both connected to one side. So let's take a look now. Here we go. Here's our multiplier. Here's our sketch of what we want to do. Again, you see the ground on the right side. Power coming out of the singles. So let's see. Two wires here where this wire is. Power on this side. Ground on this side. We look at it coming in. And now we got our spark. Let's go ahead and turn this thing on. Let's see what we can do.
That's right. Time to light it up. Oh, my favorite part. Bye. Oh, you gotta love sparks like that. That's so cool.
As you can see, we all work. It looks good.
What do you think,
it.
Gerald?
Let's go ahead and take a look
Go again,
we can do.
I love it.
That's so cool. By the way, notice the wire size and the fact that I melted one halfway through on the top. These things have very little amps in them. So it's going to fly through those little tiny wires all day. That's a cheap dollar store wire right there. And It's absolutely working perfectly. As you can see, we all work. It looks good. I like it.
Let's go ahead and take a look at the parts we needed for this project. Here are the capacitors right here, 20 kV. Here are the diodes that we used. Again, mostly important, high frequency Tesla coil diodes. Do not just buy regular high voltage diodes. They will not work.
Just so you guys know, I did buy the high voltage diodes and they didn't work. That's why I tell you that. It has to be the high frequency ones. It's just the amount of kV going through is so much that it has to have those, or else it just will sit there and do nothing.
Here's the prototyping board that I used. And just so you know, the capacitors, the diodes, and the prototyping board are all on Amazon that you can pick up. This is the AC flyback that I used. I got it on eBay. It's from out of the country, so it takes a couple weeks to get here if you order it. The last thing on the list is a ZVS. This one is a 1000 watt ZVS, the exact same one I used, and this is also available on Amazon. And this is the...
All right, I'm going to pause it right there with the circuit and just answer a couple questions. Does my drill still work? Yes, but it's dying on me after all of the high voltage it's seen in its life. So if you think that's the only test I did, no, God, no. I make that sucker, I put ends on it and light them up with high voltage, man. I completely abused that. So DC motors work perfect for high voltage. The brushless DC, not so much. It interferes with them. But the ZVS, I got it on eBay, so it's overseas. So I will attach the video in the description for this on my channel so that you guys can look it all up. It'll be in the description of the video where to get everything and what the links are. Yeah, this is really cool for this right here. I love high voltage, man. What's up, Bernie?
Heck yeah. High voltage is the best.
That's right. Wireless drill charging. I don't know if I'll probably break it, man.
I'm working on wireless right now.
Are you really?
Earlier today, yeah. I've had one of those days. You know those days where you want to go back to bed and restart the day, but you know if you do, it's going to be 10 times worse?
Yes. I'm having it right now. I've got a cold.
Oh, see? You know what? I should have got a hold of you sooner because I had one of those days today, too. Man. Blowing things up and... I don't want to get in.
I'll tell you, Gerald, I tried to... Let me put this down. Guys, I'll leave this in the description so you can take a look, but this is a circuit. Again, there's very minimal amount of parts. We're looking at $125 and you can have some high voltage fun. Again, make sure you do it with the right hand rule, or excuse me, the one hand rule. Always have one behind your back when you're doing this. This is extremely high voltage and it hurts like crazy, and don't even try to touch it with both hands. So just so you know that. But everything in that AC flyback is absolutely beautiful machine. That's the best one I've ever found. A lot of people use them out of TVs. They've always blown up on me. This one has survived for the longest. I've probably had this thing over a year, and it's never stopped. So I'm pretty happy with it. And as you can see, I do a lot of high voltage projects and kind of abuse them. So they end up blowing up, but this one lasted. Sorry about that, Gerald.
No, I was going to say fry it and find out. That's how else do you find the good ones, right?
Yeah. Oh my God, I tried to work with Z44s, the MOSFET.
Yeah, I got a bunch of those. I was looking at them earlier. No good?
I must have blew 20 of them. Like in a row.
I understand. I truly do.
I was just trying to do a simple circuit, right? Just trying to hook up my flyback transformer, and it was just simple. I only wanted to put 12 volts in it, a little higher amps than what I like. And
Yep.
that thing didn't like it at all. So I was usually running like 2 amps or under. And on this one, man, it was like 4.5 amps. So I'm thinking, well, maybe on the outside. No, not at all. Didn't like it. I got like a minute out of it and it blew up. And I'm thinking, I can't show that to people. You know what I mean?
You said what?
That's just a total disaster. So I got a transistor I got to put in there, and then we'll redo that circuit and I'll show it next week.
You can leave the door unlocked, okay?
Yeah, I'm slightly is probably not the right term. I'm not ready.
Everybody's excited for that amplifier circuit there, Gerald.
There's a problem with that amplifier circuit. My only issue is I went to test it, and for some reason I have some more testing to do before I give it up. I feel like a failure to y'all in a sense, because when I wrote it down, I separated all my notes, and I was looking today, and one of them is here from 2014, and the other one is here. It came from the same sheets of paper. You see how old that is in comparison?
Yeah.
Okay, so I'm looking for what it is that I need, and I'll tell you why. And I'll tell you why I feel like an idiot. So here's the original circuit.
Okay, hang on. Let me bring it up. Yeah, we're barely seeing it.
It's
Maybe it's a
written
little closer.
Hey, it's written with pencil, okay? And
Oh, there we go.
from 2014. So that's the original circuit. You see where it says last wire, and it says first wire,
Yeah.
and then it says center tap. The problem is, when I went to go wire it up that way, my stereo started making some funny sounds. So it wasn't the way I was supposed to wire it. And the transistor I was using went pop. I'm going to try it with a tip. What is it? A tip 31? I have it on the desktop. Just to make sure that I can get it working. I don't want to be giving it out, and because I think what I did wrong is I mixed up my output from the stereo to my input for the stereo. I don't know exactly what went wrong. I've been looking at the video trying to figure it out. So I apologize to everybody. I know everybody's excited about this circuit, but it's not ready for you. You know what I mean? Like, I have all the components. I can do the soldering on the desk live, but as far as hooking it up to your circuit, I have to test which way it hooks up properly before I give it to you. Otherwise, you may have problems.
Is the circuit right and just the way you hooked it up is wrong?
That's what I believe. I didn't have any problems with it when I was running it. Here, I'll switch cameras really quick. Yes, sir. This is the one. Well, you probably can't see much of that, though. You still hear me?
Yeah, I can hear you.
Can you hear me well?
Yeah, you're coming in good.
So this is a tip 35C. I was going to do the BeneficenceTV circuit live. So this is essentially the circuit here.
And which one was this again? You said the BeneficenceTV circuit?
No. I was going to do the BeneficenceTV,
Okay.
But this is the stereo circuit. I gave you
Okay.
the list of parts earlier. There's 4 ohms on the input, or this is on the output. And on the input, it's 270 ohms. It's a 15-watt ceramic resistor. Okay? So the way that I had it hooked up was just like this. This goes out to the stereo, and I think that's where my mistake was before. And then there's a diode that comes off of here. That goes to the coil. You check my paper. Here's another one. Horrible I am. I apologize. All right. So, yeah, this is the output to the negative of the stereo. Positive goes to the center tap of the coil. From the stereo to your coil. And then the first line of the coil goes to here. And the second one goes to here.
What about the center one on that? I didn't see any wire
That
going
center
to
one
that.
stays open.
Nothing. Okay.
Don't even touch the collector. Which is weird, but that's how the circuit ran. And that's how I was getting voltage up. This is the very first circuit I ever made.
I thought the base was the middle.
Sorry?
Isn't the base the middle, or is that a different kind of a transistor?
No, this was an MJE 13009. And it's
Okay, so
base collector emitter.
oh, so it's different on that one.
Okay? So
Oh, I gotta be careful on that because I thought all transistors were the same. Dang.
yeah, not all are the same.
Okay. What
Good
was
to
the
know.
number on that again, Gerald? I'm going to pull it up for you.
Okay, so it's MJE 13009.
MJE.
Okay.
So if you guys really want to see me solder, I'll solder it. But
Yeah. Well, let's go over the parts because I think we can get a good understanding.
And this is for the stereo amp circuit, correct?
yes, it is.
Okay. Because I tried to make one with an Arduino, and it's limited to just square, and it's not like clean. I don't know. I can't get a lot of power out of it, even though I'm getting the right frequencies. You know.
I was getting quite a bit of power, enough to make me excited that made me look deeper. And the next circuit I started playing with.
So you got power from this circuit you're talking about?
Sorry?
You're talking about you got power from this circuit?
Yeah, like I was getting voltage from this circuit from my coil, right?
Okay.
And then I started using the Tesla Slayer exciter circuit, as you can see. And I didn't like the way that was kind of turning out for my system. And that's when I found the Bedini SSG.
Okay, real quick, Gerald, I pulled it up. This is a NPN. It's
Okay.
MJE13009. And it goes base, collector, emitter. So from left to right, base, collector, emitter.
Yep, that sounds correct.
Okay, cool. Yeah, I found them on
Okay.
Amazon, 10-piece for $7.99. Awesome. I'm gonna.
That was the very first transistor I ever used that showed me ball lightning in my neon. And it was pink, blue, purple, and red. And it was spinning between the two posts in the neon.
Now, does the quality of the transistor reflect the quality of the signal or the waveform that you're producing? Because I was using the PN2222 for my Arduino. I
won't lie to you, Ben, or anyone out there. I never hooked it up to an oscilloscope. This is like my very newbie, the very first circuit I ever built. Does that make sense?
Yeah.
I
mean, I guess my
before I put
question
it
is,
together.
if I had like a cheap transistor that wasn't, like, is it possible that my transistor just wasn't working for the circuit that I'm trying to do with the amp?
I'm not sure. I needed a beefy one. I remember that.
Yeah, it's probably, I got a little tiny one.
The 2N3055s, I remember trying it with this circuit, didn't work. I fried them left, right, and center. That's why I went to the MJE 13009.
And it's also timing too, right? Some of them are faster at switching.
Yeah, and this particular transistor is extremely fast at switching.
Okay, that might be the problem. I'm using like a standard Arduino kit PN2222, and maybe it's too slow.
Maybe, or it doesn't amplify the signal enough.
Yeah, I mean, it doesn't require a heatsink, so it doesn't even have the screw for the heatsink, so it doesn't get very hot.
Yeah, that's true.
Okay, oh, sorry. It was just a question that I needed to clear up, and that answers it. Thank you.
No problem. I don't know if you wanted me to build it. I don't know if the camera can even see it properly, but that's the circuit. So what would you like me to do?
Whatever you're comfortable with, right?
Well, I won't lie to you. One of the things that went wrong today was, I don't know if you could see it's hard to see the resistors, but they were all twisted together originally, right? They weren't soldered at all. And I broke one of the wires to the transistors. I could still solder it together so that you guys can see it all together. But that's not a 13. That's not an MJE 13009. That's a tip 31. Just so that you guys seen how the circuit could be put together. That's why, like I said, everything went wrong today.
It's okay. We still have a good visual.
I do have some MJEs on the way, but they're not here yet.
Too.
Okay, I got a question for you.
Okay.
Can you go over the resistors? There's a lot on the right side, and there's only one on the left side.
So the only reason why it's like that is because this was put together out of television sets, and I had to use what I had. That's why I said in the circuit itself, let's see, it's in my book here.
This is the same circuit as the Bedini SG, or is that different?
No, this is different. This is that stereo circuit. So it's basically 8 ohms on the output, but I had set that up according to the amplifier I was using at the time, right? So you may have to tweak it. You may have to add an ohm, take an ohm away, but that's how I had it set up. I had set up 8 ohms on the back end and 270 on the front end.
So am I matching the ohms, the resistance with the resistance of the coil? Is that what you're doing?
Well, my thought process honestly was that a stereo speaker runs on 8 ohms, I believe it is, for a house speaker. And I believe it's 4 ohms for a car stereo. So my thought process was, if I used 8 ohms, I'm not going to do any damage to the stereo, because it's the same sort of around the same area. I don't know. So I don't know where. Go ahead, Nathan.
You said 8 ohms, and that's in total. And what are they? What kind of capacity? I mean, what are they?
Well, they're just ceramic resistors.
Okay.
Yeah. And I only use those because they dissipated the heat so quick.
Gotcha.
Yeah. And then the 270 ohm resistor is 15 watt. And again, I use the ceramic because at the time I didn't know better. I had no idea how to run a circuit. But I had gotten the circuit from, I can't remember exactly where I got it from. I think it was an audio file forum. Because they were testing different types of speakers, and this was the suggestion, but it wasn't the transistor. switched out transistors, and I played with the amounts for resistance on the front end and the back end before I could get it tweaked for the stereo and the coil I was using. So basically, you may have to play with their different resistant levels depending on your coil. Does that make sense?
That makes sense.
Yeah.
But that's
There's a
the
couple of
circuit I
variables
use.
involved. I should probably measure the resistance of the stereo amp just to be sure, but I think you're right. But the idea is to match what's happening with my stereo amp receiver and into a custom circuit like this, just to have a simple, replacement.
Well, how many watts is your stereo aside? Do you know?
What was it? 40 watts? Let me double check. It's an AK-45. So the AK-45 stereo amp is 50 watt, 2 channels.
Oh yeah, okay. So you may not even need 270 ohms. But it depends on the resistance of the rodent coil and your tests that you're doing. You're gonna have to it's almost like tuning you tune the circuit to the stereo.
Yeah, and that's why I think I really need an oscilloscope so I can see the signal on the stereo amp and then try to match it with the circuit and see, okay, this is a little bit different this way,
Absolutely. So I apologize to the audience. I guess I suck on this one.
You're good. I'm actually going through the old stereo amp that's blown up. I got it opened up here to see if there's any parts I can salvage for this.
Oh, there's tons of parts in there. That's like candy to somebody who pulls things apart. I do it all the time. I salvage so much. That's why
you
you
disable that so you can see it better. Hold on one second. This has got a nice, this got some nice equipment in here that I might be able to use. Original, here we go.
Nice. That's a micro amp by far.
And it's got the terminals, like you have the terminal inputs for your coil on your one circuit. I can desolder that or actually just unscrew it. Desolder it too, and put it on something for my coil. It's a good idea.
Yeah, I was the way that I had my system set up, it went to the positive to the center tap of my coil, and then like I said, the way the circuit was hooked up, and the negative went right to the negative of the circuit, and you can hear music pump through it, but I was also getting voltage on the pickup coils. So interesting.
Gerald, I have a question for you. I put up a schematic of a different circuit. Have you seen this one at all?
Not sure.
So I ask only because the center goes right to the positive of the speaker and the negative, goes out the right, just like you had.
Yep.
So you had yours where nothing came out the center. And usually that's where in the MOSFET that it trips, right? So it only goes off there when it switches. So you're not getting a switch, you're getting a straight through. Am I wrong?
Well, see, here's the thing. I had the positive of the stereo went to the center tap of the bifilar coil. So the way it kind of sets up in this circuit, it doesn't play the same way. Does that make sense?
Okay.
So I had a function generator on a tablet running from a headphone jack into the stereo, and then from the stereo, I had I'll try and get over here so I can show this. So from the stereo, you know what? We'll pull this coil out. We got B1, B2, A1 and A2, so we go A2 to B1. What I had done is I run my bifilar coil that I was using in series. So I had my A1 go to this line. Hang on a second here. I got see. This is where I messed up before. And this is why I gotta do some tests on this, but the output from the 4 ohms that goes back to the stereo on the negative speaker line, and the positive from the stereo goes to the center tap of your coil. And if I remember correctly, your A1, which is basically your positive of your primary, goes to your diode right here. So it would be like this. I apologize, everybody. I should have been ready for you. Like I said, it's been one of those days.
So you have the input and the output twisted together of channel A and B.
Yes.
That's
And
awesome.
the stereo line, if it was speaker wire, I'll try and do it like this to make it represent. So your speaker wire coming off your stereo, we'll say, are these 2 alligator clips. Your negative is going to this wire here. Your positive from your stereo is going to your center tap. And that's how the circuit, that's how I tested with it. And I had a pickup coil in here that went to a full bridge rectifier, then to a meter. So that's the circuit in its entirety. The only reason why you have all these little ugly ceramic resistors, because I didn't have a 4 or an 8 ohm. And the 270 I got through experiment from a stereo that was 100 watts a side. And that's how it's set up.
Nice.
I have to test it. I made a mistake when I first tested it, and I blew up the last MJE that I had. That's why there's a tip 31 in there. But that's the circuit I used for stereos from my very first day of testing, which I think was maybe 2008, I think. I could be wrong. My notes say that the circuit on this paper goes as far back as 2014, but I was testing with a stereo. Oh, I remember why. Sorry. Yeah. No, this circuit comes from 2014. I was testing with stereos before that, but there were car stereos I was putting up, and they were amplifiers, and I blew a couple of those up too. It's been a little while. I am reading my notes going, oh, okay, I remember that.
Gotcha.
That's like, this might be a little bit hard to see. I don't know if you want to pop this up. I'm going to switch cameras. This is something that I drew, design, never built yet. Let's see if I can get this. I did it in, it's hard to see. It's a circular Marx generator, basically. I drew it in 2015. Yeah, it's a bipolar magnetically confined Marx generator. I haven't fully built it, so it's just, I'm just throwing it out there showing you. Not something I've done.
Gotcha.
It's in the pipe, right? So yeah, that's that circuit. I don't know if that's going to help you guys. I hope it does.
I think it'll help me get the parts, so then we can figure it out and test it on live next week. So,
I agree, and I should have my transistors in by then too, so I should be able to do it properly. I ordered a couple of 8 ohm resistors, but they weren't ceramic. What was it that I ordered? I just ordered a whole bunch of stuff, so it's been a long day. Really has.
have those days.
Yeah. Go ahead.
You have those 2 that you built the last time. Can you go over them and just show everybody where everything solders in and the principle behind it?
Absolutely. I'm going to switch cameras. So you want to see the other circuits, correct?
Yeah, the ones you were just using. We saw them on those ones.
Okay. So here's what we'll do. Move this stuff out of the way. Oh, you guys are going to hear the cats now. I have no control over that. I apologize.
Oh, they're all going to tell you. They're going to hear them in the comments too.
Yeah, probably. Okay. All right, so this here, what should we go over first? Okay, so this is the Bedini circuit. This is what I use to pulse both of the bifilar, the primary and the secondary. These cables here go to one power supply. It doesn't matter what it is, DC. I can use a wall plug, a battery. I can use variac. You guys know how that works. Variac to a bridge rectifier and then to here. That power supply splits off to both transistors because I didn't want to have 2 cables coming up. So basically you have your negative going to one of these and then going to the, sorry, let me think about this. So you got your negative from, we'll say for the sake of this conversation, a battery. And from the negative to the battery goes to the coil. From the coil, we'll go through the coil. And then from the, I'm not explaining this right, I apologize. Let me get my brain straight here for a second. Okay. From the negative of your power supply to the coil of the input of the primary would go here. The output of the primary would go here. And then it goes to the E of your circuit. Your E to your emitter to your base has a diode in between it. And it goes from your pole on the diode is at the base.
Do me a favor, Gerald. Just lift that up a little bit to the camera so we can see the little diode there. Yeah, I see it. Okay.
Yeah, I apologize. I'm not doing any justice tonight. I think I left my brain back in the living room. I'm not sure. So basically, it's like this. Your primary goes to this set. Your secondary goes to this set. Your primary goes to this transistor. Your secondary goes to this transistor. On this transistor, and they're both identical, you have a diode that goes from your emitter to your base. And then on your collector, you have a diode that comes out and goes to your cap bank or your secondary battery for charging, or depending on what you want to use it for. There's a couple of different options. So on this one, the difference between here is the diode that comes off the collector is just sitting open. There's nothing with it. There's a neon on both transistors. The neon goes from the emitter to the collector. That's in case there's feedback within the system, and then you get to see the current because your neon is going to light up. Now on this transistor, I did something slightly different. What I did is from the collector's diode, I went to the positive of this 1K. Then from there, I went from the negative of this resistor, I went to, am I getting that right? No. From the negative, I went to the transistor, and from the variable, I went to this 50 ohm ceramic resistor, and then to, where did I go to with that? I have to think about that one for a second. And I'm missing wire. Oh, right. So as I went to the negative, that was the thing that I'm missing on this. That's why I confused myself. I apologize. Starting from this transistor, I went from the diode to the positive of this 1K resistor. The negative goes to the switch, then to the emitter of this transistor, and the variable goes to this 50 ohm resistor, and then back to the emitter of this transistor. Because what I was doing is when I flipped this switch and turned this power on, it was putting more power into the primary of this coil. That's what I was using for the third hop, giving it a boost. Does that make sense?
Yes, that makes sense.
I know I kind of confused things a little bit, and I apologize. It's been a rough day. So if there's any questions about this, I could take them before I move on to the next one.
Let's see.
I don't know if there is or not.
What's the diode in it?
It's 1N 4007.
4007. Okay.
It's probably overkill. I probably could have got away with a 4004, but I put a 4007 in there. And the diode coming off the collector is a 4007 as well.
Okay. So those are just protection diodes, right? That goes in between the two?
Basically.
Okay. And then where did your I'm sorry. Where does your frequency generator connect?
Oh, yeah, that's my bad. I apologize. So this is the frequency generator. You attach one lead, your negative, to your negative post to your transistor, and your positive to your base.
And it's only on that one, right?
No, if you want to pulse both circuits, you do the same to the negative on the emitter, positive on the base, and that's how I pulse both the primary and the secondary.
Nice.
So yeah, that's kind of where that circuit's at. If I messed up the explanation, feel free to ask questions. My brain, like I said, I think I left it in my living room.
What's the number on the transistor?
Those are two N3055s.
2M0355.
Yep.
Okay. Both the same, right?
Yeah.
Okay. And the potentiometer is how many? How much in there? 10K or?
So the potentiometer is 1K and the resistor is 50. But you could play with it depending on your coil. You're going to have to play with that resistance a little bit. You could use a 10K potentiometer, just taking into account when you put the resistor in between those two posts.
So like a 40K resistor with a 10K potentiometer, we should be about the same.
Yeah, it should be.
Okay. And show us how that on and off switch, which wires go to it. Can you turn it over and just show us that?
Yep. Okay. So one of these wires came out. Evidently, I must have pulled it on something. Okay. So for the potentiometer, I don't know if you can see this. The negative goes to the switch, or it's supposed to. Sorry. The other one goes to the negative of this circuit, or this transistor, which is the second. Okay, on your secondary. So it goes to the negative of your secondary, and the other one goes to the resistor, the beginning part of the 50 ohm resistor, in between the 1K. You see that?
Yes.
Yeah. It would look proper if I had it.
No, I get it.
There or something, so I don't. So yeah, that's basically how I've been running this.
So can you show us which coil it is you're running with that? Is it your big one or is it it's the little one, right?
Yeah, that one I was running the little ones with, but I've run the big one on it. In fact, earlier today, I was doing tests with the reactor. And what this does is I get very little voltage up top, very little on the sides, very little down below, and it's all concentrated in the center. Like every bit of it. And there's a purpose for that. I want to do that because I wanted magnetic confinement to something I'm going to be doing kind of along the lines, same thing Bernie's doing. Right?
Gotcha.
I don't want to say it, but along those lines.
And then that's the so we got the circuit and we got the small coil. So that's the experiment where we had the magnet on the bottom, and then we got the coil to jump, and then you got it to jump again, right?
Yeah. So what I did basically was I had the circuit hooked up. It was hooked up to 27 volt power supply on that one, I think it was. Basically, it was a 24 volt wall plug, and you know how to give you a couple extra volts. So I pulsed the primary, and then I turned on the secondary with the exact same frequency as the primary. And then, so as the primary turned on, it levitated above the magnet a little. The secondary turned on, it levitated a little bit more. Then I flipped the switch, and I would turn the potentiometer, and it would raise up to about 4 to 6 inches.
Give me a second, Gerald, and I will pull up your video so that we could show everybody real quick. Okay. So we can see it in action. Just take me just a second.
No worries.
never quick. All right, we're going to pulse it at 1,000 hertz, 1% duty cycle square wave, 20 volts per pulse. We're going to pulse the primary, the secondary, and then we're going to put a little boost on it. We're going to control the boost this time. All right, in 3, 2, 1. Now we got the primary floating. Secondary in 3, 2, 1. All right, so we got that balanced. Let's put some power into it. And we can control it as well. We'll bring it up.
That's so cool.
Down just a little. Or right back up. See, the wires are kind of making it stick a little, which is an issue for me, but let's see here. All right, everybody. You have a great day.
So now I've got it to the point where once I've turned the frequencies on and I flip the switch and I get it up there,
Yeah.
I can shut off the power on the see, brain dead. Shut off the power on the function generator and it'll stay up, but then the coil gets warm.
So hold on. So you can turn off the power on the function generator, but then the coil gets warm?
Yep. But then
So
if I go ahead.
So it's not moving the frequency through the circuit anymore. So the amps are allowed to heat up.
Exactly. See, it's part of the way that I can control the temperature in that bifilar coil.
Nice.
Part of the way. The other part, and I drew this in 2016. I don't know if I can still it.
You know what? Let me pull up your other video, Gerald, because I want to see if you use the same circuit in that one. Let me see which one it is. Let me see if this is the jumping one. I think the jumping one's on the stick, right?
It might be. Yes, it's on the stick. You see this here? This is what the outside circuit of the coil is going to look like when you're done.
Let's see if we can make it go a little higher. All right, real quick demonstration. Stick from my squeegee. You'll see why in a moment. Nothing on the secondary, just strictly pulsing the primary. We're going to see if we can make it go a little higher. Turning it on in 3, 2, 1. All right, so let's adjust this. Got like a pivotal point there, right? Now watch this in 3, 2, 1. Interesting. You see that again? In 3, 2, 1.
Man, that jumps far.
Yep.
And that's all. Was that the same circuit here as on both tests?
Yes, it was. I just put it on plexiglass this time around.
Nice.
Yeah, that way I could move it around, right, and use it and switch out circuits. And I'm working on a couple others from my book so that I can show them this week. But I didn't get certain things done that I wanted to. But we'll get there.
That makes sense. No, but I like this one. What was the other one that you had last week?
Okay, I just got to get this kitten off my shoe.
Gotta love little kittens.
Oh, they're a blast, I'm telling you. Okay, so we'll remove this. Here it is. Oh. All right, so this is the one where it's the horizontal deflection transistor, D2499, and it's the same circuit as a Bedini, except, no, wait, this isn't the same circuit. Let me think about this for a second.
That looks like a TV set circuit right there, that MOSFET.
It is a TV MOSFET. It's not the same circuit as a Bedini, though. Let me grab my book. So many circuits. All right, so yeah, this is just a regular pulse circuit, this one. It's hard to tell which one's the bottom and which one's the top. That's why I pulled this out, but basically it's like your signal generator comes from your negative goes to the emitter, your positive goes to the base. So in a horizontal deflection transistor, it's BCE, so it's base collector emitter. And in this pulse circuit, you go from your function generator, you go your positive to your base, which is this one, your negative to your emitter, which is this one, and your battery would go positive to your collector, which is this one, and negative to your collector. Sorry, brain fart. Your negative goes to your coil on your primary, and then goes through the input of your primary, and the output of your primary goes back to here. And this here is for your secondary. And this is just a spark gap. It's just a contained spark gap. I can't remember what it's called. Spark diffuser, they call it. So
is that a glass spark gap or what is it?
Yeah. It's a glass ceramic spark gap, right?
Okay.
They come out of television sets, and they call it a spark suppressor, I think. But I use it as a spark gap. Works great.
Nice.
So your battery hooks up to this one, and your function generator hooks up to this one. Your primary is here, and your secondary is here. And the reason why I've got this hooked up to two posts is because now, if I do this, oh, where's my third one?
Are you setting up a load?
Kinda. This is a hairpin circuit. Just like that. You pull the power off of here. It's a Tesla circuit that he used to tap what he called, I don't know, free energy, ether. He called it so many different things. But that's basically a hairpin circuit. You got a spark gap, you got your two capacitors, and then your capacitor that links the two, right? So you'd have your positive and negative, and then, of course, your positive and negative here, and you tap that for your load.
So hold on. He said this is for the free energy side of the circuit. Is that what you're saying?
Yeah. But in the hairpin circuit, there was two posts that would come off of wherever he had it hooked up to in his system, and the posts would come up, and there'd be a spark gap between the two, and then you would have a light bulb that sat between the two, where you could hook up a capacitor or whichever. But this represents a hairpin circuit in that sense. There's just no posts.
Huh. It reminds me of the spark gap Tesla coil, the basic one we all build.
Yep.
And it just reminds me of pulling a load off of something when you go cold energy, and it draws it back a different way.
Yeah, well, that's just the thing. The capacitors, the way they're set up, it's like it converts the energy. That spark captures as much as it can. It converts the energy through the two sets of capacitors, then to the one, and then you can use that for your load. Now, you can even hook up a capacitor bank right from there, if that's what you wanted, on that last cap.
So I wonder what would happen. Do you ever put a light bulb right there?
Oh yeah, I like to use this thing. One of these panels is 94 volts to light it, and it takes 1 amp. So what I would do is I'd hook it up to here. Like this. Or if I wanted to skip all that, and I've done this many times before, depending on the coil I'm using, I just hook it right up into here. Just like that. And I run it. And this will light up depending on what coil I'm using.
So let me ask you.
Go ahead.
Let me ask you something, Gerald. If you don't set up a load on it, or if you don't set up that circuit, or you don't set up something on that side of it, does the coil just not work?
Oh no, it works. It'll just sit there. You don't have to have a load. You don't even have to have it connected. That you get more if you do connect it. And in the different ways that you connect it gives you different outputs, depending on what you're trying to accomplish. Like if I want a ton of electrostatics, I would put a diode in there. I'd put a capacitor in there, and I'd hook it up in series with that spark gap. But I'd hook it up a certain way. And then that energy would just sit inside the system and spin. So you'd pulse your primary, your secondary would contain the energy, creating more of a magnetic field in the overall system itself, and it feeds back into the primary. The problem with that is that's exactly how you blow up an oscilloscope. So when you're testing, be careful. Make sure there's a good resistance between your, in your oscilloscope testing line. But I don't know if it will matter depending on the system, like the coil you're using.
Okay, so you get more when you put a load on it, you get more, right?
Yes, or a capacitor bank. But you know what I mean?
So you have to be drawing in more to your coil in order to get the more, right? And I'm not talking something physically hooked up. I'm just saying you're drawing more energy into the center.
Yes.
Okay. That's what I needed to know.
Yeah.
It has something to do with Joe and I talking the other day about scalar waves and stuff like that. And you said that you might be getting them in there. And you might have just said how you pulled the draw on it.
Yeah. So if let's say I'm pulsing my primary, I'll pull a load on my secondary from the cap bank. Say I'll have a diode and a cap bank set up on my secondary, and I'll pull a load off that. Because I'm pulling a load off that, it draws more more power into the system itself, and then it creates an even more of a magnetic field, which gives you more power, which, well, power is not the right term, but you know what I mean. It definitely draws in more voltage, static electricity, creating a more of a magnetic field, and just adds to the system.
Joe, we have the exact same process going on.
Yep.
That's cool. Because it gets my gravity flyer gets down, in the 40s on the degrees when you do it the right way and you connect it the right way, like you're saying, and the gravity flyer is the load.
Yes.
So it's pulling it dead center.
That's what I thought too when I seen you working with it, that the gravity flyer is the load. It's also a form of capacitance.
Yes.
And if you look at what I'm doing, I have capacitance on that load, and a load itself. So it's the same thing.
Yeah, the hardest thing in both of these things is to get past that there's a connection, but then there's metal in between. So I don't know the best way to say that. It's like the coils are stacked, but then there's a connection there that overrides another part of the connection that goes in between it. So
yeah, I know what you mean.
It's kind of hard to describe. I mean, you physically have to show each part and how it works, but yeah, I'm getting the same exact thing.
Yeah, I love these systems and how they all work. It's amazing. That this cat just totally fell. I'm sorry. I didn't mean to get distracted there.
Huh.
While we were talking, the cat crawled up onto my shoe and went to sleep. It's out like a light. I'm standing here talking to you and it's asleep.
Oh, that's so funny.
It's been an unordinary day, I'll tell you.
All right, let me put you back to normal layout.
Yeah, sorry about that. I'll switch cameras. Then all you're going to do is see me standing here.
Yeah, no, that's fine. I have some circuits to build. I've been working on my high voltage a little bit, trying to straighten it out to where I want it because it's not exactly how I want it. So there's a couple different ways to do it and different circuits to do it, and some work better on different areas than the others. If you go voltage multiplier, then that has a certain reaction, but it's harder to tune. A regular flyback gets close to the same reaction, which is easier to tune. The hardest part is the distance part, but I don't know which one's the best, so I try them both.
Well, there's different circuits, like you said, for different systems, depending on what you're trying to accomplish, right?
Right. So sometimes it's just distance. So let me see if I have a video and I'll show you what I mean. Because you saw the thing sparking over like crazy, right? On the first, when I showed you the voltage multiplier.
Yep.
Okay, so I'm going to look back. I can also get plasma from it. And then I can also get static from it.
You woke up.
I broke up?
No, the cat, you woke up. Sorry.
Oh. So hold on. I'm trying to find it. I don't know if I still have it in here. Let's see if I do.
I'm sorry. I'm trying to get my shoe away from the cat.
You should show everybody the cats, Gerald.
Yeah, that's what I did.
Oh, okay. I can't see it right now. I'm looking through my stuff.
All right. He's asleep. He's content with being beside my shoe.
Huh. Oh, I don't. Oh, here it is. Here it is. Okay. And this is something you kind of have to build to see it. Okay. So now if I can just click the right buttons here, I'll be all right.
I hear you there.
So you see the plasma in there, right?
Yep.
You guys can see it? Okay. So right about hold on. Oh, sorry. One of those days.
No problem. I understand totally.
So in this same circuit, I'm going to use it to do plasma, but you see it here sparking over.
You can go ahead and watch it, and I do the complete build.
So hold on right here. Watch it. It'll move. You see that?
Yep.
It has an initial draw. By the way, what you just saw right there was the static force that moves it. And then as soon as you saw the plasma kick in, it immediately stopped because I started to use the energy. See that? It just stopped. It wouldn't go any further. So, but the whole thing I was trying to get back to is, you see it sparking over, right? And now we want to create a plasma out of it. So the only thing, the difference is the distance. Now, this is the same circuit that I used to get all that lightning earlier. See it? It's still doing it.
Yep.
Now watch when I change it. And I'm just going to invert this a little bit. It'll take just a minute for it to... It's the same voltage. See it right there?
Oh, yeah, that's pretty.
Same exact circuit, totally different function.
100%.
So you saw earlier it moved with the static electricity, right?
Yep.
So you could see what I had to do there. It's just as simple as building a bigger coil, obviously, and then I can get static pressure, which is movement.
Yep.
So I just wanted to show that. So when we talk about pulling things in, I'm pushing it out right here, okay? And the other way, I'm pulling it in when I get the statics. So you take a look at it one more time so you can see it.
My mind's going a mile a minute right now. It's like calculating everything I've seen compared to what I'm seeing right now. And
So the cool thing is, and I'll take this off of the screen. The cool thing is to set that up. Now that's much more powerful than my regular DC flyback.
yeah,
Yeah, it's got what, like twice the distance, maybe 3 times the distance in it. So that's the circuit I want to use. I have a positive and negative. However, that's not going to work. I can only use one. And I have to use the positive. So let me tell you something about a flyback you may not understand. Or you probably will. You probably get it. One side is magnetic and the other side is potential.
Yep.
And they constantly try to attach to each other, right? So there's the cat.
did it again.
Ha! You like this shoe.
I guess he likes the warmth. I don't know. Sorry, I didn't mean to interrupt you.
It's all right. You know what? I could probably show a picture a little better. Because it matters, and I'll give out this little bit of information for you guys so that you guys understand this. Because this is going to drive you nuts. So hold on. Let me find a video that has it. And all I want to do is see it. Why do I pick videos that don't have it? Okay, that's not it.
No worries, man. Having a cold sucks. Like, I don't have a cold, but I've had one of those days, like as if I had a cold. I'm breaking stuff and dropping stuff, and I'm looking at the clock going, I'm going to be late. And it's like, oh, you know?
Yeah.
I know you're going through it, man. Sorry you are.
Okay. So that's just a picture of the gravity flare, right?
Yep.
One side of the coil that comes out of the high voltage out of the flyback is magnetic, and one side is not. Which side do you think's hooked to the top?
Definitely. I don't know. I'd say the positive thing comes to mind immediately.
So the stronger one, right?
Yeah.
That's the side that's magnetic.
That's north, I would think.
The other side's potential.
Yep. South.
So why do you think he only has magnets on one side?
To push that field up.
If I wanted to create a magnetic field between the two, yet my parts say that I only have a magnetic field on one side of my coil, I must put magnets on the other side to create the same magnetic field in order for it to operate properly.
Huh.
There's a reason why there's no magnets on the top.
That makes sense.
So he's using potential, and the magnets turn on. They're creating the magnetic field that allows it to connect to the top and come into sync with each other. That's why changing it's a bad idea, but you have to understand it, why it's going on. That's why we don't put magnets on the top, because the flyback isn't what you think it is. That's why I build them, because I want to know the exact process of how they're built and why, because it answers all the questions. So when I tell you there's a thin film of plastic, right? And all it has is a little piece of copper, like just barely any on it. That means that the magnetic field in the center of the core can only go one way. It's a diode. So when it goes out to that, it goes out to the bottom part where the negative is, right?
Yep.
That can only be potential. It can only come out as potential because it does not have the magnetic field like the main part, the red wire. It has the filtered side, and it cannot go back the other way. So it cannot be a capacitor, so it is a diode. It's more like a resistance diode because each one of those little things on the bottom has a different value to it. So it has a different resistance value. So it's a diode, but it's also a resistor. And it also only puts out potential, and that's why it's weaker than the other one, which is carrying all your magnetic field in it.
Interesting. My brain somehow went to a connection of how Tesla was using the one wire ground circuit.
Yeah.
Right. So he was putting the magnetic, but then is it the magnetic that was going into the ground? Or was it the potential that was going into the ground and he was holding the magnetic at each coil from his primary transceiver to his receiver? I'm not sure. Like I said, I'm working on a ground right now. That's why when you were saying that, my brain's going, wait a second, then does that mean that Tesla put the magnetic into the ground? Or is it reversed? I think he used the Tesla coil to put the magnetics into the ground. Because you're at a high potential with the Tesla coil, correct? Like a normal Tesla coil, not attached to the gravity flyer.
Say that one more time. On a high potential with the...
I'm trying to wrap my head around something here. So with a Tesla coil on your secondary, it's all high potential, correct?
Yeah.
So he uses that same system in order to not wirelessly, but one wire transfer his power to the other coil. So I wonder if that high potential turns into magnetics when it leaves it through the capacitor and goes into ground, and then it's picked up by the other coil that's further away by tapping into that magnetics and using it to change back into potential with the other Tesla coil. I'm sorry, it's just a thought that came to me while you're talking about the gravel flyer.
Well, it's the reason why the positive and negative charge keep flipping. Because it's not necessarily electrostatics that you're getting out of it. You're in between electrostatics and plasma.
Yeah, that's true.
So that's exactly where you want to be. And Joe and I were talking about it the other day. He thinks it might be the scalar wave is where I think it is too. Is we're attracting it right in there.
Oh, definitely. When you change magnetic field and electrostatic in between there, you get that scalar field. At least that's what I think.
So we were talking about, I always thought it pushed out and filled it up the bubble, but it's pulling in and filling up the bubble, which makes a big difference.
Yeah, but it is spitting out it's spitting out one side of it. I believe it has to. Or at least under the right conditions it does. I think it fills up the bubble till it gets to a certain potential, and then it squeezes out the bottom, kind of like when you fill up a balloon and you pull open the hole really tight and you get that farting, really squealing sound, but the air comes out super slow. Yeah. In a sense where it's like, the whole bubble stays a bubble for quite a while. I think that's what's going on, but I could be wrong.
Well, it's easier to fill it up if it's pulling it in. It just means the distance between the top plate and the bottom plate are very crucial, and not because of the weather.
Yeah, that's true.
But let me just say this. I'll say this one caveat. if heat changes your system and you're outside on a sunny day, it's going to change how much magnetic voltage you have, how much amps you have in your volts, right? In your,
Yep.
Man, well, I can't say it today. In your watt, you're going to have more amps on a sunny day than you would at a cold day.
Yes.
So
Yes.
that's what I'm trying to say. Sorry, I get head's a little
No.
foggy today.
I
But
get it, dude. Mine
that's
too.
the only difference in doing it. And the reason for that is because the distance between your plates, you're going to go from a static field to a scalar field, and then you're going to hit a plasma field. So you have to play in between the two and know exactly where it is. And then based on how much the sun's coming out, they're going to have to retract the plate a little bit in order to get that still pull the same amount. So if you don't understand temperature, this is going to be a horrifying process for you because one day it'll work and one day it won't.
Yep. That's funny you actually say that about the sun and amps because the big coil that you see before it was in resin, and I haven't tested it since it's been in resin, but before it was in resin, I could run the coil at, what was it, 528 hertz, and I'd have one pickup coil in the center, and it would run at an even 60 volts all day long. But if there was a thunderstorm approaching, the voltage would go up. If it was a sunny day, the voltage went down, but I could light more lights.
Yeah. Get more amps.
Yeah. So I think you're right. I think that's a form of tapping in a scalar, and scalar has different, at night it's higher voltage. During the day, it's higher ampage.
Yep.
It's interesting.
So the center plate on mine actually works like a diaphragm. It's not, how do I say this? I smack the outside of it, right? In
Yep.
order to get the correct octave, but it's more like a diaphragm. So I'm not trying to beat this thing to death. And when I hit the piezo buzzer on my last testing that I showed, you could hear it tap the metal, right?
Yep.
So I go ding, 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 ding. The problem with that is in a diaphragm, you don't want to dink it. You're going to use the power, right?
Right.
I need to float it. Just like that. I just want to float it. If I go ding, ding, I got problems. I just need to float it. All I'm looking to do, and that's kind of the thing, is you want to change the octave in something, right? So all I'm doing, that scale that goes on my Tesla coil like this and it goes bigger?
Yep.
Okay, that ring?
Yep.
If I'm in one octave, I hit the first ring. If I'm in a second octave, I hit the second ring. If I hit third, I'm in. You get what I'm saying?
I do.
I have to get to the last one to get the biggest value possible in order to get the right one. Once it's there, the whole amount of energy in the craft will pick up like crazy, right? Then you can pulse it and hit the more power. I have never seen anyone who's replicated one of these or even made one get close to it.
It's like you're using the ring of the plate, the sound vibrations to pull in that energy.
Yeah.
So it seems, anyway, or at least help it.
Well, you saw that Michael used those big balls, right, for the on the top of his Tesla coils in order to get the scalar to come in.
Yep.
And you notice that he grounded both of them. So
Yeah.
in the first process, all we're doing is pulling in that field. Then we're holding the field in. That's the main part of the Tesla coil. Okay? It's like a double duty system. I don't know how to explain that to people. It's the field on the outside, but it's also the coldness that goes in the center plate, which is the coldness that you're going to get. And the only way to amplify it is to pull in the scalar field.
Is there two grounds in the Graviflyer system within the circuit and the system itself?
So the Tesla coil grounds, the
Yeah.
high voltage does not. The actual gravity fire is on the ground. So I'm connecting through the ground as well.
Oh, Oh, so you do have 2 grounds.
So that's why I tell people to put it on the ground. They don't listen. They don't listen at all, Gerald.
Oh, you're just making my mind spin some more, Nathan.
I told you. I
Go
told you I
ahead.
have this thing mastered.
Yeah, man, because I just been doing things with 2 grounds and I'm seeing stuff. So that makes me think like, okay, interesting.
Bedini told you that the ground, it connects together.
Yes, but I never considered your ground for the gravity flyer being a 2 ground system. I thought, oh, okay, my brain's starting to go.
It only needs it till we build the bubble. That's what people don't understand. Kind of like, this is what I said when I saw yours jumping, right?
Yeah.
And you created the bubble. I told you there's more there because I see it every day. There's more to that in the way this works. It's you're creating a bubble, but then you're inside of another bubble as you go up.
Yep.
And it's like floating on a cloud.
Yeah, or walking, like going upstairs, and each stair is a different cloud or a different bubble.
That's right.
Yep.
That's exactly what it is. I keep saying that spiral staircase. Here we come.
Well, I said it before, and I'll say it again. If we had the resources within 6 months, we'd already be in the sky.
Yeah, we would.
Yep. Because there's things I haven't shared. It's like a magician never tells all of his tricks, right?
That's right. Hey, you can know what I do to it, and you can repeat it as many times as you want, but you'll never be able to pull it off like I do.
I hear you there, brother. I totally hear you there. Everybody's system that does work in their own way. It's all the basic same principle, but there's different ways of getting there, and I'm finding a lot more than just one, like 3 or 4 that I'm aware of.
Yeah.
I haven't proven them yet, but
all you have to do is stick to the principles of it. That's pretty much all you have to do, and then you're good. If you can understand cold energy, it makes it so much easier.
Absolutely,
because that draw is so important, man. And you see it as soon as you put your pickups in there. I see it as soon as I connect it. It's pulling in tons of power.
Yeah, I've been doing tests without the pickups too, and where my grounds go and why and how things flow, and yeah, I'm starting to see some. You're totally dead on about the bubble.
Yeah, there's no getting around it, man. It's just the way it works.
Yep, absolutely. I actually started playing with the 2 Earths because I'm looking for a cheap cap dump that we can show everybody.
Huh. Right on.
Yeah, I think we're gonna need it in order to get the energy out for people, right? Making it as easy as possible. There's a few different ways of doing it, but I'm trying to make it simple.
Yeah. I guess depending on which way you want to go with it. I mean, if you want some kind of over unity, or if you just want it to run basic, or you want some lift, it's just a change in how you connect it, and you're fine to do either one.
Absolutely. I want it to do both. I want it to have lift, and I want it to have free energy. Those 2 aspects of the system is what I'm looking for.
Well, you're kind of going to have to, because we're going to go up in a spaceship, and we're not exactly be able to pull over for some gas, if you know what I mean.
Oh, I hear that. And we're going to grow our own food from the grow room that I'm going to build on the ship, and it's going to clean our air. And there's a few things that we got going on that we can't talk about, unfortunately.
Yeah, that sucks.
Yeah. Like, I can show you this, but I can't explain this.
Yeah.
Does that make sense here?
Oh, absolutely. We're gonna talk privately on some of that stuff. So
Oh, what happened?
I see a cat. Hold on.
Hang on. I gotta set the camera up again. I forgot I took the camera off the wall because the cat, I wanted to show it, right? Let's see.
Oh, they got your chair, both of them.
Oh, yeah. They always grab my chair. It's when I'm standing.
Huh.
No, actually, I'm standing because I need to. I've been sitting too much today. That is different angles of the pyramid and different declinations of the sun going through the temples at the bottom of the pyramid, or the base of the pyramid.
Oh man.
And that's all I can say about that. We have to do it private.
You're gonna enjoy, by the way, Saturday and Monday show when you catch them.
Oh, yeah?
Oh yeah. Oh yeah. I got something special for you.
Good.
Oh, did you see the picture that I sent you?
I might. I watched the video. You talking about the Mandelas?
It had to do with the frequency thing.
Oh, I'm not sure if I've seen it.
Let me see if I can't find it real quick. I'll show you. Give you a little bit of
Yeah,
a
I missed that one.
It's all right. You're gonna catch it on the show. I got we're gonna have Joe in on Saturday.
Yep.
And then V Sears, we're gonna have it on Monday. And trust me when I tell you, you're gonna be a very happy guy.
Oh, I'm already happy. Just the fact that you're, new guests, and I love that.
Oh yeah.
You never know what you're going to learn.
We're gonna learn a lot. So I'll just share one thing. You see that?
Hang on. Oh, yeah. I remember that. I watched that. I didn't see the picture part of, well, it was in the video.
There's a lot more information that goes with that. I'll just say that. However, do you see the pattern it's creating?
Yes.
Do you remember the mandala I was showing you?
Yep. I even know how that pattern's made. I even, in my head, know the number on it.
The funnier thing is when you go scrolling through this thing, the patterns all show up in that mandala.
Yeah.
Every last one of them. They're right in there. So I think it's going to be absolutely amazing.
There's some... I just want to spew it out of my mouth, because once you hear it, just be like, really?
Huh.
But I don't want to spew it out of my mouth just yet.
Okay, we'll wait.
Yeah, I'm like, I want to just do the presentation, but I want to pick the right day. So I don't know if it's going to be Friday, Saturday. You got some guests coming on, so maybe we'll do that, and I'll do it after. Not quite sure.
Every time that we talk about something new, you add stuff to your list.
I know I've stopped now. My presentation's done. I'm finishing up on the last little bits of the editing. I did add a couple more things today to my edit. but other than that, yeah, that's I'm pretty much done.
There's got to be a cutoff and just say, hey, this is what I knew back here, and then this is what I knew forward.
Yeah, well, that's kind of where I had to put my own foot down against myself, because otherwise it just never ends. There's so much information that interconnects with this type of tech, right?
Yeah. Oh God. When I start showing my next amount of testing, Gerald, trust me, you'll understand. It's like the secret's away as soon as you do it, and there's no getting it back. And then somebody may replicate it before you do, and you're on the final stage.
Yeah, I know. That's why I want to just show it off, do the presentation, and then as others start picking it up and building their own, what else can you do, right? If this starts a movement where others are starting to build their own coils and their own systems that float, well, hey, I'm a happy camper, man.
Yeah, well, you know what? My whole thing is, as long as I know that I got it, you know what I mean?
Yeah.
Then I don't care who else gets it after that. It's just,
Yeah, pretty much. I'm not looking to make money or whatever. Although I'll tell you, once we do this, there's about 3 or 4 major projects that if anyone wanted to invest in, I'd love to sit down and talk with you. One of them's an orphanage, but the orphanage isn't a normal orphanage. It's an orphanage that teaches martial arts. It teaches how to grow food. It teaches how to build indoor grow rooms. It teaches you how to heat your home, and there's a bunch of different factors. I want to make these children that unfortunately have had crappy situations, I want them self-sufficient. If it was up to me, that's what I'd be doing. So that comes after.
well, I could go there with the Gerald. That sounds pretty good to me.
Yeah, that's my goal anyway.
Hold on.
The floating platforms for every city. But I already talked about that.
Oh, those little cats, they get me.
Yeah, they get me too. They're back and forth in front of my TV all the time.
Well, the kittens. What are you going to do?
Yeah, and when the mother comes, she gets them all upset, and then they're running all over the place, and it's crazy because she's a street cat, but she's a pretty loving street cat.
Yeah, it probably comes in and out with the babies.
Yeah. She'll come in and bring birds for them once in a while. It's crazy. That's how you know she's a good mother. So, yeah, our the next circuits that come up, I want to try and do a demonstration on using water as a ground. So I don't know if I can do it on camera. I'm trying to set up some form of a test rig so that you can all see it happen in real time. But it's tending to be a little difficult the way I want to show it. So we'll see. I can't promise anything, but I'm trying.
Yeah, you just have to be careful with that. People get the wrong idea.
Yeah, I know. So I got to get it done right. You know what I mean?
Yeah.
But,
hey, Ben, are you there, or did you? He was doing something with his coils. Did he come back yet?
I haven't seen him.
Huh.
I'm here.
You're here? Okay, there you are. Were you doing something back there, Ben? You were building something last time I saw you.
Yeah, so I'm actually working on my own stereo amp circuit with the Arduino. I did get the signal 7.83 hertz to go through to the coil, and I see a little bit of movement. Like it jumps tiny bit, but it's not enough power. And I think I need to tune the resistance a little bit, to make sure it's the signal's smooth. So what I'm doing right now is I'm taking a potentiometer and I'm going to use the potentiometer instead of putting all these resistors in series and just, adjust it like that.
Gotcha. Huh. We're going to have to figure out how to get you a sine wave. You know what I mean?
Yeah.
Okay.
Yeah. I'm going to buy one, but until I do, I have all these parts, I'll just build one or try to, at least. I got it to jump the neodymium sphere just a little bit. Just the tiniest bit, but it jumped when I turned it on. So I know it's doing something.
Huh. Hey, Gerald, do you have any suggestions for him? He blew up his amp again. Yeah.
Already?
Yeah.
I usually wait one day.
You know what Nathan says, fry it and find out.
That's right. He found out. He needs to stay away from that one frequency altogether.
Tell me something. The amplifiers that you're using, are those mini digital ones that they're cheap, you get off Amazon? They're like half the size. Oh,
Yeah, they're tiny, low power. I just mess with it a little too much. That's all. But I can build something hopefully.
you know what? I would have told you not to use those. I would have said go to your local thrift store and go buy an old piece of crap amp.
Yeah,
Because
if I can find something. Yeah, if I can find something in my price range.
Yeah, you know what? I picked some up for like $20. You don't need anything extravagant.
Oh,
As
I
long-
know. It just depends on what local supply has. So
Yeah,
I
I
paid
get
about $30 for this. If I can get something around the same price, for sure. I'll look when I get some money. But for now, I have all these parts. I'll just try to whip something up, see if I can get it to tune in. The signal, it's going through. It's just it needs to be cleaned up, and it needs to be matching what the stereo amp is outputting or was outputting. So,
Well, this is an important comment here. They ain't made for feedback of that type of energy. Those,
yeah, no, that's exactly right. That's
Yeah.
exactly that's why Daniel and Erica Nunez suggested a capacitor for doing anything HV. But I didn't have a capacitor hooked up or anything like that, and I didn't have a resistor in the series with the coil, which was also suggested.
Yeah, I've done it. I've done it in a hurry. You want to get the experiment done. You're not thinking. You hook it all up.
Because it'll fry the resistor right before it fries the amp, I guess, is the theory.
Well, that's exactly what it does, Ben.
Yeah.
You never seen the guys on YouTube just frying them for fun?
No.
Oh.
I have
Okay.
old school amplifiers. Go ahead.
Take a couple resistors when you get them, Ben, and find the recommended amount that goes into them. Then just hook up the positive and negative, one on each side, and just put a little extra in and watch it fry. Okay? Then get to understand, hey, this is why they do it, so that it fries first and saves your equipment. Okay? That's what you need.
Yep. Or you could also put an inline fuse too.
Yeah?
We can fry a couple right now if you want.
Just go to the auto parts store and pick one up.
Yep.
You just have to make sure you get the amps right, because there's got to be milliamps in there. I don't think that they're gonna pop that fuse unless we get the heavy back pressure.
You got a point there. I do.
So a resistor would probably be best.
Yeah. I get what you. Yeah. Resistor would be best. You're gonna have to map what resistance you need though.
Yeah.
Or just, I would check out and see what you get out of there. What the amps that you're getting to the volts you're getting, and then look for a resistor that has a little bit higher in that value, and then that's it. Okay, that's how I would do it, and then get also the one that's even with it. So you fry the first one that's even with it, because you're going to do that right away. Then the one that's a little bit higher, you're going to find out how much you can push it. And you might decide, okay, I'm good, or I need to go to a little bit higher than that. And then you'll be perfect. Okay. But that's how I start doing it, because I always got to fry the first one, because even never works and values sometimes lie.
That's true. Very true.
That's why I always have fry it and find out, because they tell me one thing's going to work and then it fries.
Yeah, and then it doesn't work anymore.
That's right. That Z's 44 gets me all the time. It sounds so brilliant, so terrible.
Yeah. Yeah. I have a circuit sitting on my desk. Kitten, please get off my feet for a minute.
Hey, Ben. This
Yes.
is for you. I just want to show you this because I keep hearing your keyboard. So, this is what I see in my head. You see it?
Oh, it keeps on connecting to my other mic. Does that? No, I'm supposed to be muted. What the heck?
I keep seeing this gigantic keyboard in front of him that he's punching all the numbers into, right?
Yeah, see, I'm supposed to be muted right now. What the hell?
No mute.
It won't let me switch my audio. Hold on, I gotta.
They see there's one in every office. That's so funny. I immediately saw this and I go, that's Ben. Ben's pushing those buttons again.
Big time.
Oh, man, I'm just having fun with you, Ben.
We should buy him one. That's the best.
Oh, I could get a big keyboard and a good lab coat. Get my helmet, cover up my hairline that's receding. That'd be great.
I started looking into lab coats. Maybe.
Did you?
Yeah, maybe. Might have a source. Local source too, so then I could send them out. I don't know.
Oh,
Or
man.
I might go with there's a company that does shirts and stuff like that. And I've brought it up. I emailed them, so I don't know. We'll see.
Huh.
Just brain farting all day today.
Yeah. I got such a cold, brother. It's bad. It's like it's killing me. My granddaughter came over, and she had a little runny nose, and she would get upset a lot. And I was just going, man, I don't really understand. And then now that I have her cold, I really get it.
Yeah. Now you know why she was upset.
Oh yeah, because I feel like crying too. To be honest with you.
Oh, I hate
This thing. I woke up this morning dying, man. Everything leaking. I gotta go blow my nose and everything. It's just horrible.
I'm sorry, I'm not laughing at you, but you reminded me of Star Trek when McCoy asks the captain that isn't the captain yet. He's like, "How do you feel?" He's like, "I feel leaky."
Yeah.
Sorry, that just reminded me of that.
Oh man.
So I have a device that we can not this time round, but I build this on film. Holy, date myself. Build this on camera, and then we can go over it next Wednesday. It's Alexov self-charging circuit. And I've built this one before, and it works. And it's very easy to build, actually. It does take an MJE 130009, but it's basically 2 100-turn wraps. It's like bifilar wound on a broomstick, right? And then the way the circuit's set up, it charges 48 volts, like a 48-volt battery bank. And I tested it. It's awesome. And it's solid state. It's just, you hook it up and it goes. Takes a 12-volt 8-amp-hour battery to run it. But, yeah, it charges a 48-volt battery bank.
Let me show you guys real quick. So it finally finished printing out.
Oh, that's pretty. Look at that. Do you already got the coil in the middle?
Yeah, well, I haven't put the wire on it, but yeah, I've already got it all printed out, ready to go.
Nice.
So it's big, man. So I didn't just do that one. I have another one too. So let me see if I can't grab it real quick while I put down the camera.
That's really cool.
That's the rodent coil, yeah?
Yeah.
Okay.
And that's good one.
So check this out, Ben. This is for you, buddy. I got another set being built, the exact same size as your orange one. And that's why I was asking you about the wire size. The cool thing is you set it outside and it glows in the dark purple.
Really? Wow.
Nice.
Yeah.
That's so cool.
So, yeah, it's getting there. I got a stack. I got to build some more. But I wanted to put it outside, and bring it back in and have the purple show. I think it'd just be amazing.
Now I'm all jealous. I want mine to glow
Neat.
purple. No. That's cool, man. That's really cool.
Yeah, I got orange and some other colors in glow in the dark. I think I have green. I should have probably done it in green, but I had the purple right there, so I grabbed it.
I don't know. Purple kind of goes with the high voltage thing, right?
Yeah, well, kind of my style. So I got some work to do, man. I just got to figure out which wire to use because I have 20, 22, 24, 23, I think, gauge wire. And then it goes up to 28. So I don't think I have 25. I might. But they're different colors. So, a couple of them are green. A couple of them are red. And then I got a couple of gold ones in the higher numbers.
All those gauges are good for what you're doing.
Yeah. So I think on that bigger one, it might be, oh man, I want to go 20 in the center and 28 on the outside. And I want to see how close I can get them together. And it just resonating. So it would have to be the same weight.
Right.
So that's going to be a little bit more agonizing to pull off. I'll have to stretch it out, see how the distance is, and then put it on the scale, see what the weight of the distance is, and then calculate it out. So it'll just take a couple extra steps, but I can get that done. And then for the smaller one, I think I'm just going to go 20 red.
Oh, yeah. Yeah.
So I think that's going to be cool. Because green, I don't think it's going to look good with purple.
No, it'll look like the Joker coil. Right? Green and purple?
Yeah.
That's the colors of the Joker. So, yeah, you don't want to do that.
Nah, I think I'll just stick with the red. I think I'm okay there. I'd like gold, but I didn't get it this time in that color.
Yeah. Get 24 karat gold. It's, yeah, get that.
Somebody did black. They had a black wire. And I want to get some of that. Yeah, it was black. They did their Justice Coil in black. It was awesome.
Go black and red. That would look really cool.
Yeah.
Yeah.
So they did black, and then I always saw the blue out there. So the blue I want to try as well.
Yeah. I've seen blue. Seen a few coils done in blue. It looks really neat. I tell you, though, the gold and the silver, I'm almost done. I wanted to show it this Wednesday, but it's not ready yet.
Not ready yet?
No. It's going to look cool when it's finished, though.
Oh, man. Hey, I just want to show this because we're getting close to the end here.
Yeah,
I want to just light up some voltage one more time.
Yeah, make it go boom.
The schematic that we use today.
So for those of you who missed the beginning of the show, this is what I did. I built this voltage multiplier. And it's a negative voltage multiplier. I went through exactly how I did it. And it came out real nice. It didn't take that long. I think I spent an hour because those diodes are small. And there's a whole circuit in here with all the different parts. And I'll make sure I put this in the description. But I also drew it out here. You can see it. Exactly how it flowed. To make it easier for everybody to understand. And then my favorite part. As you can see, we all work. It looks good. I'll try it one more time. Sorry, I got to do it again. It's high voltage, man. Oh, it's so nice. I miss that sound. Yeah. As you can see, we all work.
That blue color, along with the purple that you've seen inside of the cylinder that you were doing of copper, along with the red, that's the colors that was inside that neon when I seen ball lightning for the first time.
Really?
Yeah, it was insane. I didn't even know it was ball lightning until about 2 years later.
Nice. Oh,
Yeah.
just one thing I just wanted to show you as well, because I showed it earlier. That wire, I burnt it right there at the top, right at the end of the screwdriver thing.
Yeah, you can see it.
Dude, you know how many wires I burnt like that? And I had them on the table, right? So
Yeah.
they all start lighting up against things when you start putting them towards metal. So they'll find the point where they, dude, it's like the worst thing in the world when you forget that you burnt something, because then everything starts lighting up on the table. That's how I lose a lot of stuff. Go ahead, Joe.
Oh, I was just gonna say that wire where it burned. Did it burn because it was just over the drill, or did it just burn because it's a weak spot?
So I think I was using the DC flyback and I got a little extra amps in it, and then it needed to break out. So it broke out, and then it's been that way ever since.
That makes sense. That makes sense. That's a freaking gorgeous. Love that spark, man. I'd love to open like a portal with just that blue. I don't know if it's possible, but that'd be gorgeous.
Yeah, that's the coolest thing, man. And the crazy thing, that's just a 24-volt battery.
It's amazing what you can do with 24 volts.
Yeah. You get
Yeah.
24 volts, you get that. It's massive. So
It's weird because if I put too much power into the coil, I get less out. Like if I go past 32, 36. Yes, I have spark envy. I'm kidding. I'm just going with the comment here. That's awesome.
you know what, Joe? Yeah. I have the same thing right now. My gravity fly, I can't use this. I can't. So
Yeah.
I don't get to spark up stuff like I used to. Used to be every day, plasma display, spark it. You know what I mean? Have a little fun, get zapped a couple times.
Blow some stuff up. I set up that capacitor board, but I haven't got it to go off the way I want to yet. So when I get the right capacitors, I will show it. I don't know if you remember me talking about that, where you blow up all the capacitors. Yeah. So I set it up, but they're not all blowing up the way I want. So I'm playing, but I'm going to show that to the audience.
Nice.
It's cool. Yeah, it's cool.
I ordered those little needle things for that small testicle, the one that zapped me last week. That thing that they called a tool to help you. It didn't. It was a zapping machine, but
it's like a kit, right?
Yeah, it's just one item. It's just this. So.
Oh yeah, nice.
And so it lights up the plasma bulb. You know what I mean?
And it's only one? It doesn't come with a bunch of different ones?
No, it does. It comes with all the different pieces here.
Oh, okay, yeah. Like a kit.
Remember those? Yeah.
See, those things are awesome.
And then I got the little needles on their way, so hopefully they'll be here soon. And then I can transfer it into that little mini Tesla coil that Sean made.
Yeah.
And I can start lighting up the breadboards and stuff with it. So
that would be interesting.
I'm gonna have me some fun. I'm gonna touch everything with it.
That'll be interesting.
It's a mini Tesla coil. I got a couple of coils that I wound, like this one right here. I'm gonna put some Tesla coil power into that bad boy.
Yeah, see what happens.
Yeah, I'm just gonna do it to everything. I come to the realization that that's about what's gonna happen.
That should be like a Friday night special or something, right? What are we doing tonight? We're putting a Tesla coil to it. What is it? It's a microwave. Who cares?
Oh my God. I'm so tempted to do that. I don't think you understand. It's been so long. When I get over this cold, man, I think I'm just going to set things up to spark. And I'll just start demoing one after the other after another.
You see what happens to it, right?
Yeah, well, I know what's going to happen eventually, but eventually it's going to get me and some people are going to laugh. But I can't avoid it. Sometimes high voltage just zaps you.
Yeah, I was watching you comb your beard, so.
Dude,
keeps going. Oh, it was awesome.
That was like the best, wasn't it?
Yeah, I want that system. I do. I got too many other things on the go right now, though. So maybe in the future.
That's gonna be fun though, man. I look forward to that. So
I got a couple things for notes for next week. We'll do this Alexa self-charging system. I will have this stereo circuit tested and ready to show. Otherwise, anybody can talk circuits, right? But at the same time, I want to test it for the public. That way they see it. But I didn't use it on what Ben's using, that digital amplifier. It's not set up for the same sort of, like, it won't handle feedback whatsoever. It just blows. But the old amplifiers that I have that I use, man, it'll handle feedback all day long. You know what I mean? And that's the amplifier that I used it on originally. So
get you an old Sony or an old Yamaha.
Yeah. Techniques. There's so many different kinds. Yeah.
Well, I always say they're on offer up for $30 to $40. You can find them at $20 sometimes. Yard sales, you can pick them up for $10.
And it doesn't matter if one side's blown, because you only need that one side for testing. Right? But I think you wanted to cut out soon. Yeah, is that what you had said earlier?
Yeah, dude, I'm dying right now.
No, I understand. I don't want to.
I keep turning off my camera because I have to blow my nose, man.
Yeah. I can hear you suffering, brother. Let's cut it short. Short, 2 hours.
Yeah.
But yeah, we should call it a night, and we'll get back at her next week.
Yeah. You got any updates going
on? So yeah, I just got the Arduino code compiled. I don't know if you can see that, but this is my circuit that I'm going to be testing tonight. It is going to output 7.83 hertz, and it has two 10 unifarad capacitors and also a 100 k ohm potentiometer, along with a P2 or PN2222 transistor, and also a 1K ohm resistor. So this is going to be used. I'm going to try to fine tune it and see if I can get the neodymium sphere to spin. What I'm doing is trying to replace the stereo amp, and at the same time maybe input a little more juice.
I think Russ.
I don't know. I might be limited with the Arduino, but we'll still see if we can get a clean signal. It should still, spin the sphere a little bit.
I think Russ Grease from RWG. I think now it's a number like 3495 or something. But RWG Research, I think he did something similar with our Arduino on a 2N22. I could be wrong, but you could always look him up for circuits for stereo too.
Yeah, I'm gonna see. The problem is that I only have that one transistor, the PN2222. So until I get another, more suitable transistor, it's gonna be limited, I guess.
Yeah, if you were, down here or up here in Canada, I got boxes of old TV parts, and just pick a few, man.
Yeah.
One day we'll get you up here one day. But I think Nathan wants to cut us out here because he's dying, the poor guy.
If you guys got something more, go for it.
No, I'm about to spark one up, Nathan.
Yeah, I've had one of those long days, so I don't mind cutting it out.
Yeah, same.
No, man, we covered a lot of circuits today, and then hopefully you'll have all that stuff straightened out by next week.
Yes, definitely.
Yeah.
And I won't be so brain dead. At least that's how I feel today, I'm telling you. Not as bad as what you're going through, though, Nathan. I don't want that.
So our guest on Monday is V. Sears.
Nice.
He's going to be coming in on Monday. And then Just Straight Dope, or Joe as I know him, will be in on Saturday. So
Nice.
we'll at 10 a.m. we'll kind of take a look at it and go over everything, and we'll talk about the scalar waves.
Yep.
And the effect and stuff like that's coming in. And then V Sears as well. He also works in scalar waves. He also looks at radio fractals. So there's a lot to cover in what we're doing. And it all falls in line with where we're at, guys. So
I love it.
we're going to have a lot more information. And then some people reach out to me on Facebook. So we're going to have a couple more people. So I want to get my buddy with the high voltage in here soon, because of course I love high voltage, but it's what it does that's going to make the difference. So
yeah, and we haven't discussed electroculture. We haven't even gotten into that aspect of this system, which goes along with the third part of it. I think we can still talk about electroculture. I don't know yet, but I know the other.
You might have to be careful with the wording. That's all.
Yeah.
I'll have to go look into that, but yeah.
Yeah, they're just all about direct use, kind of, in that area. Not so much of the outside fringe part of it, if you understand what I mean.
Sense.
So
that makes sense. Awesome. So when V Sears comes in for fractal antennas, that will coincide with electroculture in a sense. So.
Well, there you go. So don't miss Monday, because that's going to be totally awesome.
Oh, yeah.
You know what? I was in awe having the conversation with him. Let me just tell you that. It was absolutely fascinating.
Nice.
And my brain was triggering everywhere. And I'm just thinking, man, I wish Gerald was sitting right next to me, because this is just one of those awesome conversations. So
nice.
I'm really excited about it. So I think it's going to be really good.
I'll be there.
And then, like I said, Saturday, man, that's always an interesting conversation. When you get into it with Joe, you go all around the world, man, in like an hour or two.
Yeah, I watched his interviews there. So, yeah, I definitely want to get in on that.
Yeah, and then he got his site set up for his YouTube.
Nice.
And he put a song on there that he had wrote, and they put it through a AI thing to bring out all the music and everything on it.
Yeah.
So totally awesome song, by the way. And then we'll probably play that on Saturday. We show his channel. I told him I got to make one too. So
definitely get that link out to us too, and we'll check it out.
Yeah. A lot of software links going to be going on in the next two, things.
Nice.
So
I like that.
All right, guys, I'm good. That's all I had going on. How about you guys?
I'm good.
I'm good.
All right, guys. Thank you all for
thank
you all for showing up tonight. I appreciate you guys in the chat, hanging out with us and talking with us, learning some circuits and having some fun. I got to spark something up, so I'm a happy guy, even though I'm dying right now.
Without you, we wouldn't be here. So please.
Yeah, we love you, Nathan.
Back.
We love you. We love you too,
guys.
Gerald. And we love you, chat.
We'll catch you all very soon.
Right on, guys. Have a great night.
Later. Guys.